Good afternoon. Thank you very much, Professor, for introducing me. I'm pretty loud, I thought. Okay, nevertheless, I will try to use this. First of all, I would like to thank the organizers for inviting me to give this presentation. It is a great honor to share my research with great scientists sitting in front of me. I could see the great scientists in front of me right now. So it is a great honor to come and give a presentation. I've been visiting Korea a number of times. Probably I'm meeting Professor Yo Rinklabe and Philip Tag more frequently than meeting my wife. So that's how I'm traveling these days. The diagram of presentation, biochar. We have been listening to a lot of presentation on biochar, including a nice presentation by Dr. Liu from Zhejiang University. So quite a number of people have been presenting. So this is the outline of my presentation. Briefly, I will introduce biochar and carbon sequestration, because the whole concept of biochar started about carbon sequestration and carbon storage. That was the original thought. So therefore, I will introduce why biochar in relation to carbon sequestration. Then I will talk about my main talk, which is biochar modulates or improves soil health. Increasingly, they thought biochar not only add carbon, but it improved the soil physical, chemical, and biological fertility, which Professor Zhou just explained to us why carbon is so important. So I will discuss about how biochar can improve these properties. Then I will provide some conclusion. So if you look at that, video, this is my neighbor who got some biochar sample and trying to put it into a garden. So biochar application is becoming more and more common. May not be in a massive amount, but as a nutrient source. So I will explain why biochar can be used as a nutrient source. Now biochar and carbon sequestration. Carbon sequestration or carbon storage in soil is one of the methods through which greenhouse gas emission can be mitigated. Professor Brian he explained why by increasing 0.4% carbon in the soil, you can overcome some other problems. Soil carbon sequestration strategies include conservation tillage, which is no tillage, so that we don't release much carbon, soil amendments, compost, biochar, crop rotation. However, intensive farming practices involving some of these strategies, adding fertilizer for example, can lead to depletion of carbon from the soil. So therefore, the compost and biochar came into play, how they will improve the carbon storage. Applying organic waste could increase carbon storage in soil and contribute significantly to the reduction of greenhouse gas emission. But there is a problem. Some of the compost, including biosolid, the rate of degradation is much faster. So therefore, you will be releasing some of the carbon dioxide into the soil. So they can become a source for greenhouse gas emission rather than a sink. That is where the biochar concept came. So the conversion of this biomass material, bio-waste material, including biosol, into biochar reduces the rate of decomposition so that the carbon become a recalcitrant carbon or long-term stability of carbon in the soil. So that is how biochar become an important source of carbon storage in the soil. You are all very familiar with this diagram. One is, this is the natural carbon cycle. Carbon comes through photosynthesis into the biomass, then through respiration from soil and plant, it goes back, what we call carbon neutral. Whereas this is the biochar cycle, around 50% of the carbon you convert into recalcitrant carbon. So in the case of regular carbon cycle, almost 100% goes back, whereas in the biochar cycle, you store the carbon in the soil. So that is how biochar becomes a source of carbon input into soil. But that's not the main presentation of my talk. So my talk is more about how biochar modulates soil health. We undertook a major meta-analysis work. These days, everything is to do with meta-analysis. We look at the publication. I can have a smile from the editor there. So we look at more than, I think, 353 publications. Around 45% of them is from Professor Oak. This on biochar work, because they are the pioneer in this area. So we look at a meta-analysis of these biochar samples, both laboratory studies, incubation studies, and field experiment, and look at the value of these in improving some of the physical, chemical, biological fertility. So that's what I'm going to present now. Before I introduce that topic, this is the classical layman's diagram about biochar. It is the temperature, this is the carbon recovery, and these are some of the important properties. So the biochar properties, pH, cation exchange capacity, surface area, which impact soil health, depends on the nature of the feedstock and pyrolysis condition. What I'm trying to tell you is that there is no single biochar which you can apply to the soil which does the magic solution. It all depends upon what feedstock you are using, what pyrolyzing temperature you are using. Now let us come to the main topic, which is, let us start with the physical properties. What we did is, this is the meta-analysis. So you can see in the x-axis, percentage change in physical properties. And these are some of the physical properties. That's the positive change, increase. This is the negative change. That means the change in some of these properties compared to the control soil where you don't have the biochar. So when that means it's an increase. So some of the properties we look into, that is penetration resistant, hydraulic conductivity, clay content, which is the aggregate stability. Hana give a nice presentation on aggregate stability, water-filled pore space, and bulk density. So you can see that biochar application improves some of these soil physical fertility properties, including bulk density. When it is a heavy soil, it decreases the bulk density naturally because biosoil is lighter. It increases the porosity, increases the hydraulic conductivity, aggregate stability, ultimately moisture holding capacity. What I have presented there is clay. Biochar doesn't increase clay content. However, when you do soil fractions, you include biochar as less than 0.2 micron. So it becomes a clay fraction. It's not actually a clay. So that's why there is an increase in clay content. But biochar does not increase silicate clay content. So that's. So, however, you can see that biochar, the effect of biochar on physical property is what we call dose dependent. So this is the relationship between biochar dose and bulk density. You know, bulk density is an important component of physical fertility. When the bulk density is very high, you will have a compaction problem. So we would like to have a moderate bulk density. So the bulk density decreases with increasing biochar, simply because biochar is lighter and it provides more porosity. However, that gives the hydraulic conductivity and also air-filled porosity. These are very important. So that is a completely different shape. You can see that as the level increases, there's a decrease in hydraulic conductivity, but at high rates, both hydraulic conductivity increases and also air-filled porosity increases. So what I'm trying to say is that it depends on how much biochar you're putting. What is the quality of the biochar and how much biochar you're adding. Now let us look at chemical fertility. I can't give much data on physical fertility because not much work done on the value of biochar in physical fertility. A lot of work on chemical fertility, which I'm going to show you now. I'm a soil chemist. I love soil chemistry, so therefore I'm a bit biased, unconscious bias. Now this gives the same meta-analysis of physical property, chemical properties. There are too many bars, so you can see that trace element, which Professor York Winkler loves it. And this is magnesium, calcium, sulfur. We call it the secondary element. Then you have phosphorus, nitrogen, and potassium, primary nutrients. So you can see in all cases, there is always an increase, simply because biochar contain all these nutrients. You make it from bio-based, plant of origin. So they contain all these nutrients. Therefore, you increase the nutrient content. Then let's look at what we call cationic chain capacity. Negative charge. Negative charge is nothing but cationic chain capacity. Then pH. We all know that biochar has a lot of negative charge. Brian explained today morning there is a potential to increase the positive charge also. By adding biochar, you can increase the cationic chain capacity. I'm a soil scientist. Cationic chain capacity is one of the most important property of a soil, because that's how it retains some of the cationic nutrients. And then pH. pH is very interesting because majority of the biochar seems to be alkaline. So that's why it's always an increase in pH. There are some acidic biochar, but most of the biochar are alkaline, so you increase the pH. You increase the pH. By increasing the pH, there is some consequences there. I'll show you that. Ammonia volatilization, for example, it will increase. Now let us just give you some example of nutrients. So these are some of the nutrients: nitrogen, phosphorus, and secondary nutrients, and potassium. You can see that most of the time, the nutrient content, they will have a high nutrient content. But what is interesting is biochar made from manure samples and biosolid sample invariably contains higher nutrient level, simply because the feedstock contains more nutrients. Recently, one of my students, this is my current student, he took manure from every animal in the world, including even rabbit, wallaby, alpaca, duck, and including biosolid. So this gives the nutrient content. You can see that nitrogen, phosphorus, and potassium. So this project is all about biochar as a nutrient source, what we call nutrient enrichment. So the biochar sample from this manure sample contain high levels of nutrient, went up to 7% phosphorus. It's almost like a fertilizer that's in the biosolid, and high levels of potassium, 5% of potassium. What I'm trying to say is biochar can be a good source of nutrients. In relation to nutrients, I just thought I will show you the dynamics of some of the nutrients. This is for nitrous oxide emission. We listened to a presentation in the morning. Biochar can reduce the nitrous oxide emission. There's a lot of debate about that. Some cases, biochar increases the nitrous oxide emission, but majority of the research decreases the nitrous oxide emission. This is the work done by one of my good friends, Professor Wang Heilong's work. So the biochar addition reduces nitrous oxide emission from the soil. The reason being, it will reduce the nitrate source, and also it changes the soil water content, because nitrate is the primary source for nitrous oxide emission. Increasingly, they have shown that biochar can also act as a nitrification inhibitor, so thereby reducing nitrous oxide emission. Now in the case of, this is ammonia volatilization. We have a problem. So you can see that there are 3 biochar sources. There's biochar 1, 6.2 pH, biochar 2, 10.2, that's the control one. So when the pH of the biochar is higher, there is an increase in ammonia volatilization. When the pH of the biochar is less, there is a decrease in ammonia volatilization. We all know that ammonia volatilization is purely a chemical process. You take ammonia salt, like ammonium chloride, add sodium hydroxide, you get ammonia gas. It's a purely chemical process, nothing to do with biology. Whereas nitrous oxide emission is a biological reaction. So the biochar addition has been shown to both increase and decrease ammonia volatilization. That's simply because how biochar influences the soil pH, which I can demonstrate here, because this gives the pH and ammonia volatilization. As the pH goes up, ammonia volatilization increases, because you can see that increasing pH, NH4 become NH3. It's a pure chemical process. I always stress this point to my students. Nitrogen cycle is dominated by microorganisms, but ammonia volatilization is purely a chemical process. That is, nitrous oxide emission or nitrogen fixation is a biological process. So while the increase in ammonia volatilization is attributed to increase in soil pH, there are times it can decrease because biochar can increase the retention of ammonium, therefore it will reduce ammonia volatilization. Because biochar has a lot of negative charge, NH4 is a cation, it retains and reduces ammonia volatilization. So it pH dependent. So to conclude the nitrogen dynamics, how biochar influences the nitrogen dynamics, biochar impacts nitrogen transformation such as leaching, which I didn't show you. A lot of studies have demonstrated that, and gaseous emission through physicochemical absorption. Good example is nitrate absorption, ammonium absorption. Biological immobilization, because biochar can host a lot of microorganisms, which I will show you again. Nitrification inhibition, and finally, it will change the soil properties by increasing the pH, or changing the pH, or controlling the soil water content. Let us just look at briefly about phosphorus and also potassium. This gives the anion retention capacity of different biochar. We produce a range of biochar with different anion exchange capacity. And this is the amount of nitrate and phosphate leach. You can see there is a drastic decrease in nitrate leach with increasing anion exchange capacity. Anion exchange capacity is nothing but positive charge. Nitrate being a negative charge increases. And this is for phosphorus, phosphate. Not that drastic. But if you just look at that point, so number one, the decrease in the leaching of anions such as nitrate and phosphate is attributed to adsorption, precipitation, and immobilization. So this is where this particular biochar, I think we got it from again, very high calcium and magnesium, so which precipitated phosphate. So precipitation is an important process. So just look at the phosphorus dynamics again. The biochar application impact phosphate leaching through physicochemical absorption. It may not have much positive charge, nevertheless it will absorb phosphate, biochemical biological immobilization more on precipitation reaction, simply because biochar contains a lot of calcium, magnesium, you can precipitate as calcium, magnesium phosphate. The last one is about potassium. I told you I will talk a lot about nutrients. So this is the typical cationic chain capacity versus potassium or ammonium leaching. Both potassium and ammonium are cations. Cations and cationic chain capacity is nothing but negative charge. You can see that biochar has much higher negative charge. Soil maximum 50 millimoles per kg, whereas biochar can have up to 100, 200 millimoles per kg. So with increasing cation chain capacity, again there is a decrease in leaching of both potassium and ammonium. But one danger is majority of the potassium in biochar itself are soluble. So when you introduce biochar, which contains a lot of potassium, there is a likely chance of leaching of potassium. Whereas biochar can retain soil potassium by absorbing potassium, which is cationic chain capacity. So the decrease in cation, such as potassium and ammonium leaching, is attributed to absorption with increase in cationic chain capacity. So we have explained how biochar can provide the nutrients and also alter the transformation of the nutrients, thereby increasing the soil chemical fertility. The biochar and cation dynamics, we talked about nitrogen dynamics, phosphorus dynamics, cation, which include potassium. So the biochar application impacts cation interaction. This is the classical diagram by Professor Oak's book. We borrowed that. Through absorption, because they have a lot of cationic chain capacity, biological immobilization, precipitation, and redox reaction. Just want to touch upon redox reactions. A typical example is chromium. Hexavalent chromium get reduced to trivalent chromium because biochar provide electrons, because biochar is a highly reducing agent. So therefore, hexavalent chromium, which is highly mobile, highly toxic, can be reduced to trivalent chromium. Thereby, you can achieve the reduction in the toxicity of hexavalent chromium and the immobilization of trivalent chromium. So redox reaction play a vital role in nutrient and heavy metal dynamics in biochar amended soil. Now let us look at the biological fertility. We talked about physical fertility. It improves mainly the bulk density. It improves the water holding capacity. It improves the hydraulic conductivity. Therefore, it provides physical fertility. When we look at the chemical fertility, it's mainly by providing nutrients, simply because biochar contains the nutrients, and it also alters the transformation of the nutrients. A typical example is reducing nitrous oxide addition, increasing the retention of nitrate, increasing the immobilization of phosphorus. Therefore, you reduce the leaching of these nutrients. So therefore, you provide more nutrients to soil. So finally, biological activity. The biological fertility. There's not much work on biological fertility. So we couldn't get too many indices of biological functions. So therefore, what we are given there is an enzyme activity, dehydrogenase enzyme activity. We always use this an index of soil respiration, microbial biomass carbon. A lot of work has been done on that. Substrate-induced respiration. This is when you add glucose, how the respiration. This is the basal respiration, which is very commonly used. So you can see the change in biological property. Most of the time, there is an increase in the biological function of soil. So the biochar application improves soil biological activity as measured by basal respiration, substrate into respiration, microbial biomass carbon, and enzyme activities. I think this is one area which requires a lot of work because it's after all a good carbon source, whether that will improve the biological function and biological activity. How it improves biological function and activity. This is a classical diagram by Lehman et al. And also morning I saw Dr. Liu's work from Zhejiang University, very classical work. That picture gives the association and colonization of biochar in biochar when you apply to the soil. So the biochar induced increase in the abundance of soil biota is, they have given two reasons for that. Number one, it provides the improved resource due to co-location of various resources in and around biochar. So it's what we call co-location. It provides the nutrients. It provides the carbon. That's number one. Number two is the absorption and thereby inactivation of growth inhibiting substances. So the biochar removes the inhibiting substances which are inhibiting microbial activity. Excuse me. Above all, biochar provides habitat for microbial function. So just about the conclusion, thank you for the timing. We went to Fiji I think a couple of months ago, because there is a decline in sugarcane cultivation, which they are attributing to climate change. You all know that Fiji Prime Minister is very passionate about climate change. I think he was the chairperson of the climate change, UNESCO climate change. So wherever we went, the first thing the farmers will say, my sugarcane yield has gone because of climate change. It may not be anything to do with climate change, but they are so passionate about their leader. So what I'm trying to say is, if the leader believes in climate change, population believes. The sad part in Australia is we had a severe drought, I think last year. And you go to the farmers, they just don't want to believe in climate change. That's the reason, because the national party which the farmers are following, they don't believe in climate change, just like Donald Trump. So what I'm trying to say is, what the leader believes, the followers believe. Okay? Farmers are very resilient. I'm not saying that they may not believe in climate change, but they adapt to the climate change. They are more intelligent. The farmers in Australia are more intelligent than scientists like me. So I never say that it's all ideology. It's all about passion. So the conclusion, biochar application improves soil physical properties such as volcanicity, porosity, and moisture retention. Biochar contains most of the plant nutrients. Increasingly, we want to make biochar as a carbon source fertilizer, what they call carbon fertilizer. And the concentration of nutrient depends on the nature of feedstock material and pyrolysis condition. This is where Professor Zhou, Yang Zhou mentioned about, the organic manure may not be a good source of nutrient. Biochar can be a good source of organic nutrient, carbon nutrient. Biochar application increases soil cationic capacity and also soil nutrient concentration. It decreases nutrient leaching and also gaseous emission, nitrous oxide, to some extent. Biochar application improves soil biological health, thereby increasing the productivity. So what is the take-home message? I always love this picture. The take-home message is this: biochar application improves soil health, thereby increasing crop production and reducing the environmental impact of nutrient losses. Just one thank my past and present postgraduate students, because they are the people who did the work. I'm here to present the work. Once again, thank you for the opportunity. It's a great honor to give a presentation in front of great leading scientists. Thank you.
It's not a presentation, it's a very excellent lecture on biochar and soil. Do you have any question or suggestion? Okay.
Respected professor, being a fish or fishery scientist, I'm working on fish particularly, that is ichthyology. We call in water body, soil is the nursery of fishes. Soil is the nursery of fishes. So whatever the nutrients which is available in the soil, that will be taken up by the fish. If we use biochar in the fishery or pisciculture, because as you know, in India particularly, you are from India also, in India, pisciculture is one of the most economic business in our country. So if we use the biochar in the pisciculture sector, either in the prawn culture or in the freshwater fishes, whether it would have been able to raise the economy of my poor cultivators or farmers? What is your thinking, sir? Have you been applied this biochar in pisciculture?
Thank you very much for that. It's a great question. The only time I applied biochar, to some extent activated carbon, when my wife was having a fish tank with full of fish, because they produce a lot of ammonia. Ammonia is highly toxic to fish. So we used to put activated carbon and biochar to capture the ammonia, because we don't want to kill the fish. But in relation to your fish culture, it's an industry. Honestly, we haven't done any work on that, and I don't know whether there's any need to push biochar in a fishery culture. Whereas Professor Oak is here, Professor Zoe is here, some of them may be able to answer this question. I'm not in the fishery culture.
As you have mentioned, the ammonia,
Yeah.
it is trapped by the biochar.
Yeah.
But whereas you have mentioned the level of the ammonia will be rise due to biochar.
No, I didn't. The ammonia, depending upon the pH of the biochar,
Yes.
the ammonia volatilization, NH3, ammonia gas emission, can go high if the pH of the biochar is very high, because ammonia gas emission is purely a chemical process. When the pH goes out, ammonia gas simply disappears. Professor Zoe knows very well. It's a pure. You take ammonium chloride and add sodium hydroxide, boom, comes ammonia gas, which is highly toxic.
Only one more request, sir. When you have mentioned the scanning electron micrographs photograph during your bioactivity, biological activity, you have not mentioned the magnification of it.
That's actually not my picture. Actually, it is from Professor Dr. Lawsby. But it's also layman's. Thank you, sir.
If you have any questions? Okay.
For the question, actually, the Professor Ming Ong was the first plenary of the ARC. He talked about the topic actually using the biochar as a fish feeding material. So that was, he got a patent and technology transfer to company in Hong Kong. So that's kind of relatively big scale that he's doing. So maybe we can talk after that. Yeah,
Sure.
My question is
Oh yeah,
he's there. Sorry, I was looking in the behind. Yeah, he can give the answer. Yeah, sure.
Well, not answer, some hints perhaps. I think all along we have put activated carbon into animal feed, ruminants, to absorb all these gases, you see. And then people also put them into poultry feed for chicken and so on. Now, in terms of aquaculture, people put biochar in the water for purifying the water. For example, like ammonia absorption and also perhaps heavy metals and so on. Now, recently, we have been working on a proposal with Professor O and try to use a small amount of biochar into fish feed. And we would look at the microbial flora in the gut because we believe that the microflora could flourish and then help the fish to digest all this food waste and other content, ending up with a very good feed conversion ratio. Thank you.
Thank you. Thank you, Sue. I have last question to you. Usually, I thank you for your excellent lecture. Usually, lecture covered the advantage point or disadvantage point also, which you introduced some disadvantage point of biochar.
It's a very good question. You are right. I'm very positive about biochar. Of course, there are issues with biochar. A typical example is ammonia volatilization. Because you don't want ammonia, because quantitatively, ammonia volatilization is much higher than nitrous oxide emission. As a farmer, I'm more worried about ammonia volatilization because I'm losing a lot of nitrogen. Nitrous oxide emission is not very much. It's more environmentally, people are worried about nitrous oxide as a greenhouse gas emission. Whereas ammonia volatilization is much higher. As a farmer, I am more worried about ammonia volatilization than nitrous oxide emission. So therefore, if the pH of the biochar is very high, we really get into trouble because co-composting is becoming very popular these days. You compose the biochar with manure. So you have to be very selective in selecting the nature of the biochar. Professor Joe Winklebeck, he is the expert in producing different kind of biochar. He has a very beautiful review. So it all depends upon the feedstock and also pyrolysis temperature. I just give you one example why biochar may not be good. If I give too many examples, Professor Oak may not like it because he invited.
Thank you very much. Please give him a big hand.